Welcome to qnawire.
To begin this question, we remember that the ground state wave function for the hydrogen atom is given by this equation. Then, to calculate the absolute value squared, we just have to square this equation, so we get this result. Then, the probability density for the ground state of the hydrogen atom is given by 4 pi r squared times the absolute value squared, which yields this result. Then the probability of finding the electron within a radius capital R is equal to the integral from 0 to capital R of the probability density dr. The question gives us several values for this probability and wants us to find the values of the radius. This is a fairly difficult question, and it begins as follows. So the first thing we have to do is evaluate this integral using this expression. It goes as follows. The integral from 0 to r on dr of 4 times r squared e to the minus 2 times r divided by r0 over r0 cubed is equals to, we can put these factors outside the integral to simplify some things. So 4 divided by r0 cubed times the integral of r0 to r dr r squared e to the minus 2 r divided by r0. Now we do a simple substitution by defining u as being equals to r divided by r0. With that, we have du is equals to dr divided by r0, and then dr is equals to r0 times du. So now we have 4 divided by r0 cubed times the integral from 0 to, when r is equals to capital R, u is equals to capital R divided by r0. The integral is now on du, but remember dr is equals to r0 du. So we have du r0 times r squared is r0 times u squared times e to the minus 2 times u. Now, this is equals to 4 divided by r0 cubed times, we have one factor of r0 here and two factors of r0 here, so there will be an r0 cubed outside the integral, times the integral of du u squared e to the minus 2 times u from 0 to r over r0. Now, we can further simplify our calculation by simplifying these two terms of r0 to get 4 times the integral from 0 to r over r0 du u squared e to the minus 2 times u. Now we do another substitution, which is the following. Define v as being equals to 2 times u. And now we have dv is equals to 2 times du, so du is equals to dv over 2. Then we have the following. 4 times the integral from 0 to 2 times capital R divided by R0, because v is equals to 2 times u, on dv, but du is equals to dv over 2, so there is a factor of 1/2 here. U squared, u is equals to v over 2 squared e to the minus v, and this is equals to 4 divided by 2 to the third, one factor of 2 coming from this fraction and the other one coming from this fraction, which is squared, times the integral from 0 to 2 times r divided by r0 dv v squared e to the minus v. Now, simplifying this, 4 divided by 8 is equals to 1 over 2 times the integral from 0 to 2 times r divided by r0 dv v squared e to the minus v. Now we keep that result for now, and we will use it later. Now we have to solve another integral to be able to evaluate this kind of weird integral. Now note the following. Let us define an integral called big I, which is a function of, say, w, and this big I integral is equals to the integral from 0 to w of dx e to the minus alpha times x. So this is big I alpha of w. Note the following. If we derive this big I integral with respect to alpha, we get the following. This is equals to the integral from 0 to w of dx. The derivative of an exponential is itself, but we are deriving with respect to alpha. So we get a factor of minus x here, and that's it. So note that applying the derivative with respect to alpha in this function results in a new factor of minus x here. So guess what? If we derive it twice, we get the integral we are trying to solve, which is dx x squared e to the minus alpha x. This integral is very similar to that one. We just have to change, if wanted, v to x, just rename it, and then set alpha equals to 1 and w equals to 2r divided by r0. So what we have to do now is to solve this quite simple integral here. So big I alpha of w is equals to the integral from 0 to w dx of a simple exponential. The integral of an exponential is itself e to the minus alpha x divided by minus alpha, because when we derive e to the minus alpha x with respect to x, we get an extra factor of minus alpha. And this is from 0 to w. So this is equals to 1 divided by alpha minus e to minus alpha w divided by alpha. Finally, the result of this integral is 1 over alpha times 1 minus e to minus alpha times w. So this is I alpha of w. We have to evaluate the second derivative of this integral. So the first derivative is as follows. d big I alpha over d alpha is equals to the derivative of the first one, which is minus 1 over alpha squared times the second one, plus the first one times the derivative of the second one, which is minus w times z to the minus alpha w. The derivative of 1 is equal to 0, 1 is a constant. And this is e to the minus alpha w minus 1 divided by alpha squared plus minus plus w e to the minus alpha w divided by alpha. Then we can now evaluate the second derivative. The second derivative is equals to the derivative of the first one, which is minus w e to the minus alpha w times the second one, which is 1 over alpha squared, plus the first one, e to the minus alpha w minus 1 times the derivative of the second one, which is minus 2 over alpha to the cube. Now we have the next term, and then again, this is the derivative of the first one, which is minus w e to the minus alpha w multiplied by the second one, which is 1 over alpha, plus the first one, which is w e to the minus alpha w multiplied by the derivative of the second one, which is minus 1 over alpha squared. Now we can organize all these terms to get the following. 2 times 1 minus z to the minus alpha w divided by alpha cubed minus this term, which is e to the minus alpha w times w. Now plus minus this other term, which is w times e to the minus alpha w, and this is all divided by alpha squared. And finally we have the last term, which is minus w squared e to the minus alpha w over alpha. Now we can organize this a little more to get 2 times 1 minus z to minus alpha w divided by alpha cubed minus 2 times w e to the minus alpha w divided by alpha squared minus w squared e to the minus alpha w divided by alpha. Then we can keep organizing it as follows. This is 2 divided by alpha squared minus 2 times z minus alpha w divided by alpha squared minus 2w e to minus alpha w divided by alpha squared minus w squared e to the minus alpha w divided by alpha. Then we can write it as follows. This is 2 divided by alpha squared minus e to the minus alpha w times 2 over alpha cubed plus 2 over alpha squared plus 2w over alpha squared plus w squared over alpha. And now we have this result. We can use it on our previous integral, which was this one, to finally write our result. So this is d squared I alpha over the alpha squared, and then we had the following. We had the integral from 0 to 2 times capital R divided by R0 dv v squared e to the minus v. This is equals to d squared I1, so alpha equals to 1, evaluated for a value of w that is equals to 2r over r0. Then we get the following. This is 2 minus z, the minus alpha w. Luckily alpha is equals to 1, so this is very simple. This is 2 plus 2 times 2, 4r over r0 plus 4r squared divided by r0 squared. Then there were the prefactors, which was 1/2. So finally we have the probability of finding the electron within a radius r is equals to 1/2 times 2 minus z to the minus alpha w times 2 plus 4r divided by r0 plus 4r squared divided by r0 squared. Note that I forgot to substitute this w here by 2 times r over r0, so let me do that. So we have minus 2r over r0 here and here. And finally, simplifying a little bit more, we have 1 minus e to minus 2r over r0 times 2 divided by 2 is 1, 4 by 2 is 2, and 4 by 2 is 2 again. And this is as far as we can go with this question. Now, we would have to solve this equation for given values of PR. So, for instance, in the first item, PR is equals to 50%, Then we have 0.5 is equals to 1 minus e to the minus 2r divided by r0 times 1 plus 2r over r0 plus 2r squared divided by r0 squared. We can solve this equation numerically using a computer for r divided by r0. By doing that, we get r divided by r0 is approximately 1.3. Then, in the first item, big R is equals to 1.3 times R0. In the second item, we have 90%. So, we solve the same equation using 0.9 is equals to blah 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 blah, which is just this other term. By doing that, we get R divided by R0 as being approximately 2.7. Then, big R is equals to 2.7 R0. And finally, for 99%, we have 0.99 is equals to blah 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 blah, which is again this term here. And by solving for R divided by R0 using a computer, we get R divided by R0 as approximately 4.2. Then R is equals to 4.2 times R0.